In this video, we shall be looking at Jacobian. This is MTH381 Mathematical Method 3, specially built for the National Open University students. So if you are undergoing the course and you find or you stumble across this video and the video is of benefit to you, you can leave a like, subscribe to the channel, and share the video to your colleague. So we want to look at Jacobian and how to solve some questions that involve Jacobian. But before we do that, let's see what Jacobian is. Jacobian is a functional determinant. Jacobian is a functional determinant. So now, let's see what determinant is. If you remember how to find determinant in a matrix, okay, in case you have forgotten that, let me quickly show you how to do that. Let's say that this is a matrix. We have 2, 3, 4, and 5. Now, if this is a matrix and you are asked to find the determinants of this matrix, let's say that this A is equal to this matrix. So we want to find the determinants of A. So what you do is that you are going to multiply the leading diagonal, that's 2 times 5. So the determinants will be 2 times 5, then minus, multiply the second diagonal, which will be 3 times 4. So 2 times 5 is what? 10. 10 minus 3 times 4 is what? 12. So if you take away 12 from 10, you are going to have minus 2. So the determinants will be minus 2 there. But when it comes to this Jacobian, we say that Jacobian is a functional determinant. So we want to find the determinants of functions. That is what Jacobian is all about. So now let's say that let's define a function. Let's say that let u be a function of x and y variables, and v be another function of x and y variables. So let u be a function of x and y, and v, x and y be two given functions. So let this u and this v be two given functions. Now in this case, you know this x and this y are independent variable. X and y are independent variable, while u is a dependent variable. Now let me explain that to you. Now if we have u of x, y being a function, if this is a function, now this u depends on the value that x will take and the value that y will take. You get that? So let's say that we have a function f of u, which is equal to, let's say, 2x plus 3y. Now this function u, the value of this u is going to depend on what x is and what y is. For instance, if we have f of u to be equal to, let's say that x is equal to 2 and y is equal to 1. So if x is 2, that means 2x will be 2 times 2, which is 4. Plus, if y is 1, that means 3 times 1 will be 3. So this 4 plus 3 is going to be equal to what? 7. So at this point now, when x is 2 and y is 1, the value of this u is going to be equal to 7. Now if x becomes 3 and y becomes 2, the value cannot be 7. The value cannot be 7. So it shows that This value of y depends on the value of x and the value of y. So therefore, we can say that x and this y are independent variables. They do not depend on any variable. Okay, so let's go back to what I was saying. So let's u of x and y and v of x and y be two variables. Then we can define Jacobian. Then Jacobian of these two functions will be equal to the partial derivative of u v all over partial derivative of x of y. So now this will be equal to, now this is the formula for finding Jacobian of two functions. So this is going to give us partial derivative of u with respect to x. Then here we have partial derivative of u with respect to y. Now down here we have partial derivative of v with respect to x. Here we have partial derivative of v with respect to y. So this is what you need. This is what you need to find Jacobian. So the Jacobian of two functions is equal to the partial derivative of this u with respect to this x, then the partial derivative of this u with respect to y. Then below we have partial derivative of v with respect to x, partial derivative of v with respect to y. Okay, so now let's solve a question. Let's use this to solve a question. Okay, so now let's find the Jacobian of this. Let's start with the simple to the complex. We want to find the Jacobian of a function here. So let's find Jacobian of the Jacobian of, now let's say that we have function x. Find the Jacobian of x equal to u plus v and y equal to u squared plus v squared. So we want to find the Jacobian of these functions. Now we have to recall this. We have to recall the formula that Jacobian is equal to what? Now in this case, now we have this x is a function, this y is a function. So we are going to have something like this: partial derivative of x with respect to u. Then here we have partial derivative of x again with respect to this v. Then below it we are going to have partial derivative of y with respect to u. Then partial derivative of y with respect to v. So this is how the formula will look like in this case now. So now what do? We are going to find the derivative of x with respect to this u. Then that will be the value of this. Then we'll find the derivative of x with respect to this v. That will be the value here. Then we go to this place, derivative of y with respect to u squared. That will be the value here. Derivative of y with respect to v squared. That will be the value here. So now let's find derivative of x with respect to u. Now if you are finding the derivative of a letter like this, the answer will be 1. Derivative of x with respect to u is equal to 1. How is it 1? Now, if you are finding derivative, that's the x du. The x du. The x du of what? Letter u. Now, to get that, now, if you use the general formula of finding derivative of function, this letter u has coefficient of 1 on top here now. So what you do is that you are going to multiply this this power. It has a power of 1, so we multiply this power of 1 by this letter u. So 1 times u is what? U. When you multiply this power by this u, you are going to take away 1 from that power. So 1 minus 1 is what? 0. And anything raised to power 0 is what? 1. So that's how we got the derivative of this letter u to be 1. So the x du is equal to 1. Then what about the x dv? There is plus here. So this thing and this u and this v are separate. Okay? So you are going to find derivative of x with respect to v. You are also going to get 1. So because you just follow the same process now, just that this letter will be v. So you get 1 there. So that means this place will be 1, this place will be 1. Okay? So let's write that. You have gotten here to be 1. 1 here, 1 here. So what we want to find now is this derivative of y with respect to u square. So let's say that dy du of u square. Now this u has a power of 2. So multiply this 2 by this u. That will be 2u. Take away 1 from this 2. 2 minus 1 is what? 1. So there is no need of raising this u to power of 1, because anytime you have power of 1, just leave it alone. So that will be 2u. So here we have 2u. Then do the same thing here. dy dv. dy dv is going to be dy dv of v square. So multiply this power of 2 by this v. That will give us 2v. Then you take away 1 from this. So that will be 2v. So you write it down here, 2v. So now we can find our determinant, which is the Jacobian. So cross multiply this leading diagonal. 1 times 2v is what? 2v. Then minus, cross multiply the second diagonal. 2u times 1 is what? 2u. So now at this point now we can just factorize this. 2 is here, 2 is here. So we can take 2 as a common factor, bracket open. So 2 cancel 2v. So it will remain v there, minus 2 cancel 2u. That will remain u. So this becomes our Jacobian, which is the answer.